Welcome back to Bazai. This crash course turns the messy process of building an AI system into 6 crisp stages, from defining the problem to deploying a production API. Use it as a checklist for the next project or to debug why an existing model isn't landing results. Setting objectives. Start with a business use case. What decision or workflow should improve? Run a quick feasibility study. Do the signals exist? Can they be collected legally? And is the payoff worth the cost? Then define success with concrete KPIs, accuracy/recall for classification, ME or RMSE for regression, latency, and cost for serving, and human satisfaction metrics if there's a UI. Lock scope and risks early. The model is a means to an outcome. Data preparation. Data work dominates timelines. Collect, integrate sources, log events, and design feedback loops so labels keep arriving. Clean, deduplicate, fix schema drift, handle missing values, and track lineage. Feature engineering. Create informative signals, normalize and encode categories. For LLM/RAG, craft chunks, embeddings, and metadata. Split. Stratify into train/validation/test to prevent leakage. Time-based splits for temporal data. Document bias hotspots and privacy constraints before training. Choose the algorithm and framework. Match problem to approach. Tree ensembles or linear models for tabular baselines, CNNs or transformers for vision, sequence models for time series, and retrieval or RAG for knowledge grounding. Start simple to set a strong baseline, then layer complexity only if it beats the baseline with statistical significance. Pick a framework that fits the team and infra, PyTorch, TensorFlow, scikit-learn, and prefer battle-tested libraries over custom code when possible. Train the model. Feed the model, then iterate. Use the validation set to tune hyperparameters, learning rates, depth, regularization, augmentation. Add guardrails, early stopping, cross-validation, and robust seeds. Track experiments with version configs, data hashes, metrics, and artifacts so the best runs are reproducible. For LLMs, monitor token budgets, context sizes, and alignment data quality. For classical ML, watch bias variance and feature importance. Evaluate and test. Holdout testing is non-negotiable. Analyze metrics that reflect the real risk. ROC/UC may look great while recall in a rare class is poor. Run bias and fairness tests across key cohorts, add calibration checks, and measure latency and memory at target batch sizes. Create red team, test cases, and drift canaries so failures surface before users do. If the model doesn't move KPIs and offline tests, go back to data or features first. Deploy the model. Choose a serving pattern. Batch scoring for nightly reports, real-time APIs for interactive apps, or streaming for event pipelines. Containerize the model with its exact environment, expose a stable contract, and instrument